Hi everyone, this is Dana and Alex with Disruptive. We've got Jason Kelly and Anna Marie today from Ginkgo Bioworks. Couldn't be more enthusiastic for this opportunity to learn more about what you guys are doing and how you're going to change the future for us all.
Absolutely. So a lot of the questions that are generated from us are not only from us, but also our followers on Twitter, across a lot of social media platforms, because my biggest belief is that Ginkgo right now still remains highly misunderstood by retail investors. And that's exactly what I want for this interview to do, is to educate them across the whole board of what you do and many others. So can you explain what synthetic bioengineering is and why it is essential to not only the present but also the future?
Yeah, and it makes synthetic biology is even a new word for a lot of people, right? So the way I think about it is, inside of every cell is digital code in the form of DNA. Mm-hmm. Right, so it's A, T, C's, and G's. It's not zeros and ones like in a computer, but you can read that code with DNA sequencing, like you've heard of, like genomics, like the Human Genome Project, that sort of thing. That's DNA reading. You basically take a cell, grind it up, put it in a machine, and on your computer it'll show A, T, C, G, G, G. And then we also have DNA writing, DNA printing. And it's the exact opposite. You go on your computer, you type A, T, C, G, 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 and you guys got to see the labs today, right outside the window over there. A machine's going to make that piece of DNA to spec as you type in the computer. And so if you can read and write code, and you have a machine that'll run the code, which is sort of how we think of a cell when it comes to DNA, well, you're programming. And so what synthetic biology is basically building the tools that allow us to program cells to do new things.
Do the things that we want them to do.
Yeah, I mean, do all, if you think about biology, it's this interesting substrate that we take for granted.
Yep.
Right? Right? You grow up with it, you get a pet dog or house plant or something, right? But think of when you plant a seed, right? You put a seed in the ground, you add air, water, and sunlight, and this thing self-assembles itself out of thin air. It makes solar panels, right? And starts producing food. Like what the heck is that? Right? Like if you thought of it on a technology basis, like if Apple came out with the seed, right? You'd be blown away at the sophistication. And we're just like, oh, yawn, right? It's a plant. Because we're around it all the time. And so you kind of know that biology's got it in it. And what we've lacked is the ability to make it do something other than kind of what evolution gave us over the last 4 billion years, right? And so that's what synthetic biology is to say, hey, what do we want biology to do to make our lives better, right? And so that's a big part of the applications, yeah.
So our multimedia company is called Disrupting. We're here today because we believe you guys epitomize, the meaning of being a disruptive company. Can you summarize why Ginkgo is disruptive and what industry sectors are ripe for Ginkgo to disrupt?
Okay, yeah. So the way Ginkgo sees the world is just like in software, you have these big horizontal platforms, think operating systems or programming languages, right? Like you didn't have market-specific operating systems. You had one big platform, right? Like something like Windows or iOS today. Well, the reason for that is inside the computer, the bits that are flying around don't know that they're going off to YouTube or to an electronic medical record or something like that. They're just bits, right? And so when we looked at biology, we saw the same thing. Inside every cell is digital code in the form of DNA. It's not different by species. Your cells read the DNA the same way an insect does or bacteria. And that's not market specific. So there should be, if you wanted to build programming tools, they should be horizontal across all markets, right? And so that's fundamentally what Ginkgo's building. It's a platform to program cells across all markets. So which ones will it disrupt?
Yes.
Well, let's look at computers, which was the other programmable technology. You put in different code, the machine does something different. Just like a cell, okay? Except a computer, what does it move around? Bits, information.
Yep.
So what were computers disruptive to over the last 60 years, right? Information-based industries. Media, telecom, finance, advertising, everything that involves pushing information around. What didn't they disrupt? Well, hamburgers, right? Like hamburgers were not disrupted by computers, right? All right. Cells, they programmable, put in different code, do new things. They don't move information around. They move atoms around. They build stuff. So if you think of them, they have that disruptive potential of putting in different code, but the industries that are going to get disrupted aren't the information ones, it's the physical goods industries, right? It's food, it's textiles, it's medicine, it's electronics, it's all the stuff, right? And you're seeing that, like the Impossible Burger. You tell that story. That's a synthetic biology product. That's the first disruptive product in the burger industry in 100 years, in my opinion, right? And so that's because biology builds stuff, right? And does that make sense in terms of the where it could go? And I'm happy to give specific near-term examples, but that's like the big vision is all the physical goods industries.
And that's why you guys are an organism company.
Yeah, that's what leaves the door here, right? What leaves the door of Ginkgo to our customers is a cell that we program to do something new, an organism. It's alive. And we give it to you, and you go off. It's your app, right? You go off and bring it to market. And then our business model is just like engaging with like a mobile phone app store, right? The mobile phone company is giving you a bunch of services. They're giving you distribution. They're giving you tools to program those apps, make it easy to put something on your phone. In exchange, they'll take 30% of the revenue, for example. So all right, well, same idea here. If you use my platform to get that program cell, I'll take a piece of the downstream value of your app. And it's a good trade, right? Just like it's a good trade to be an app developer on mobile phones, that you can make a lot of money doing apps and the ecosystem is provided for you. Same thing we're doing here, except our apps are live cells.
Makes sense to me.
Well, I have to say is that when people looked at Ginkgo, there's a lot of people that just look specifically that you're just a pharmaceutical company.
Yeah.
You're like a healthcare company,
Yeah.
which is not the aspect in any shape or form. You're going for more than just that. And truthfully, you're working with Biogen, you're working with Motif, you're working with many companies, Bayer, Join Bio, but you're not just a health company. There's so many more aspects to you. So that's why you're more innovative and more disruptive than people really give you guys credit for.
Yeah, so I think the reason for that is the history almost of the word biotech. So if you think about, I'll just give you a little bit of the background. This is kind of cool. So like the history of the pharmaceutical industry came out of chemistry.
Yep.
Like Pfizer, these companies were chemical companies, and then they basically took what our first drugs were, which were like plant extracts, and then they used synthetic chemistry to make things like aspirin, your first like small molecule drugs. And that was the drug industry for years and decades, all the mid-century. And then along 1978, there's the invention of what's called recombinant DNA, basically cutting and pasting DNA. So cutting a piece of DNA out of this organism and pasting it in over here. You can't change it, but you can cut it and paste it. And the company Genentech comes along. By the way, we have we're getting the DNA ticker. It's the old ticker for Genentech. So I'm like so proud of this. Yeah, like when we complete the merger with SRNG, it'll become DNA. But Genentech comes along and they take the gene for human insulin and they paste it into bacteria, into E. coli actually, and then they grow it up in a big tank, and it makes human insulin, and they had to give it to diabetics. Right, my dad was a type 1 diabetic, so he was starting in his 20s. He was a diabetic as a kid, and so he had to take pre-Genentech insulin, which was from pigs. So you used to extract it from pigs, and it had all these side effects and stuff. And then Genentech comes along like, no, we'll give you the real stuff. We'll give you human insulin. And then they said, oh, well, let's also do EPO for like these blood, all the other these protein drugs came along, and that became the biotech industry. And it was pharmaceuticals, but it was the application of cutting and pasting DNA that enabled this whole new category where today now, like nearly half of the approved drugs, I think it's like 40%, are biotech drugs.
Yeah.
Okay, well, the low-level technology was cutting and pasting DNA. It just happened that the first market, and the big one, was drugs. So we all think today when we hear biotech, we think drugs. But that just happened to be like the first killer app. Right, like in our life-saving app, right? But like the actual low-level technology is your ability to edit biology, and the first time it just showed off because all we could do was some stupid cut-paste was human proteins. Does that make sense?
That does make sense.
So we're still stuck with that. When people hear biotech, they always think drugs. That's why, right? But what they really should think is like programming organisms and what could it do. And as we get so much better at it than we were in 1978, the markets are going to be well outside of pharma.
Well, it's fair to say you guys pioneered this whole new section. You're the industry leader in it.
For synthetic biology, I'd say at this point we're the industry leader. Yeah, and with this idea of you can use the same infrastructure to program a cell for any market. Right? Like most of the other people in the space, they have a certain product they're going after. They are a drug company. Or they are an ag product, or they want to make a food, a Impossible Burger. Like their company is about the product, which is great. But when it comes to being about the kind of the operating system, the Amazon Web Service, like the platform, I think we are the leader there for sure. Yeah.
You keep on going and bringing up the word like program. How is like biology programmable, and also with that, like how does that coincide with the mission for Ginkgo Bioworks as a future? You kind of gave it, but can you give a little bit more perspective into that?
Sure. Yeah. So here's what's magical about biology, right? So if you think about what life does, it's basically like giving birth to an offspring, and it wants to communicate the genes, like some information from the parent to the offspring. And biology freaking figured out the exact same thing that we figured out mid last century, with the advent of computers, which is if you want to communicate information with high fidelity, the best way to do it is digitally. Remember, there's like records and stuff. That's like analog, like waves and all that crap. But if you really want to get it exactly the same, use a CD, right? And that digital information transfer is also really good to pass information to your offspring. And it's freaking what biology invented for DNA. Same. What's that?
Scalable.
It's scalable, and it's high content fidelity, right? Like it passes the information well. And so along we come here, human beings, again late 1970s, and we're like, holy crap, it's digital code. Like, why don't we edit it? Right? Because digital code natively is easy to work with. And so that's really why we say it's programmable. It's because, like, by some miracle, right around the time we were figuring out the structure of DNA, we're also inventing the first programmable human technology, computers. And we're like, oh my God, right? It's the same thing. Yeah. And so we like that language, right? Now, we're also like, the founders are all like MIT nerds who are like computer scientists and kind of came into this as a bunch of, computer and engineering folks. And so it made sense to us. Yeah. Right? When we saw biology, we saw code. Yeah. That's a little different than like how the biologists see it a little bit at the time.
That's a deep vision.
It's cool. Yeah. It's really exciting. Like, and I think it's something that, like, as a society, we need to like build comfort with and think about, right? Because it is a big deal.
It's a new concept, yeah.
Yeah, and biology does a lot of important stuff for us, by the way. Like produce the atmosphere, make all our food. Like, we're made out of biology, right? Like, so as we enter like this era of being able to design biology, like it's a collective topic. Right? Like, we all need to decide like what the right thing is to do with it, and companies like Ginkgo need to build trust with the public. Like, I think it's amazing what you all are doing, talking to people out, just general public about investing in companies. Like, people need to understand us, so that we can build trust with them, because we're deploying powerful technology. That's important to me, right? And so it's like one of the reasons I think what you all are doing is great.
Awesome.
Well, thank you.
Thank you. Appreciate it.
We know that you guys are concentrating on solving some vitally important, problems, like replacing petroleum, based chemicals, animal-sourced food products, agriculture without harmful fertilizers. What other areas is Ginkgo disrupting? Are there any like quick and easy wins that you think of? And what challenges do you have to overcome to tackle bigger problems?
Yes. So the first thing I would say is, like, if you said a company was going after all those things, someone would rightfully say, that's freaking crazy, it's too broad, why did you focus, right? And so the reason that Ginkgo can actually be in all that stuff is it's our customers that are doing that.
Yep.
Right? Bayer Crops, like a $100 million joint venture with Bayer. They want a microbe that's engineered to produce fertilizer for crops, right? It's called Join Bio, our joint venture. Yeah, and so it pulls nitrogen out of the air and fertilizes the crop, so that you don't have to put synthetic nitrogen fertilizer on there. That's the spec of the program they want written, that cell program.
And so there are plants already that do this.
Yeah.
Like, I think it's peanuts.
Yeah, exactly, legumes.
Taking that genetic code and then replicating it for like wheat, corn, and rice.
Yeah. So I'll tell you the story because I like it, because I was a chemical engineer at MIT. So the way that is today, by and large, is a process called Haber-Bosch. Like the pride of chemical engineering, invented by the Germans, and you basically you pull atmospheric gas, which is like 70% nitrogen, through a big chemical plant. You burn natural gas, all right, and you take the nitrogen, you put it with the hydrogen, and you get ammonia. And it is like not small. It's like 4% of global greenhouse gas is just making synthetic fertilizer. Wow. It's a huge environmental impact, but you get $70 billion a year of bags of fertilizer that you ship off to farmers. They put it on fields, and half goes as a runoff, creating a local problem. Yeah. You get an atmospheric problem, but we all got to eat, right? Like otherwise, this was the whole green revolution and part of what happened in the 50s. Because there was a lot of people might remember there was a big concern that like we were going to overshoot our food supply.
Yeah.
Well, part of the way we solved that was Haber-Bosch. The other way was dwarf crops, was actually genetics, breeding the corn so it wouldn't fall over when it had more corn on it. But anyway, those two things together give us the food we have today. All right. Well, certain crops like legumes, like soybeans, fertilize themselves.
Sure.
How do they do it? Well, on their roots are microbes running Haber-Bosch. They're literally pulling nitrogen out of the air and fertilizing the crop for free.
Yep.
And so if you remember like crop rotation, like in elementary school, like that's what's going on. You plant the legume and it like leaves behind some fertilizer, then you put in a different one, and so you can like re-fertilize the soil naturally, right? And so that process works great in legumes, but corn, wheat, and rice, half a global fertilizer usage, they just didn't happen to evolve to have these microbes.
So that's a $70-some billion industry that you guys are going to disrupt.
It is an industry today that is effectively a $0 biotech industry.
Well, and you figure too, just you're curbing pollution drastically, right? Because there's runoff of all these chemicals in the existing model.
Yeah.
It goes into the rivers and the foods that we're consuming.
It's an awesome end application, yes. And what we would do is we would take the microbes that live on corn, and you would read the DNA of the microbes that live in soy, find the part of the code that says run Haber-Bosch, and move it over, right? And now, you have to then redesign it 100,000 times and all this stuff. Like there's a lot of work, but that's the goal. And then if you do it, yeah, you're 100% right. That taps into a market that today is a $0 biotech market, but could be a $70 billion biotech market.
Are there
right?
any other like quick wins? You guys know you could tackle.
I wouldn't call that a quick win.
That's a quick win. We have to times this corn kernel for 10,000 times.
Yeah. That's a real project.
Well, it's
yeah,
one
for sure.
that you can wrap your mind around.
Yeah, I'll give you another one I like.
Yeah.
So have you had an Impossible Burger?
Not yet.
I have.
You have had one?
I'm curious.
Yeah.
Okay, right.
It was all right.
Yeah. So I like burgers, right? Like I had a lot of burgers as a kid, and so you bite into the Impossible Burger, and it's a veggie burger.
Yep.
But it bleeds.
Beet
Gross.
juice.
No. Actually.
What?
Yes, you said beet juice.
Oh.
So you bite into this and you're like, what is going on? And you would think beet juice, but beet juice doesn't taste nearly as good as what Impossible does, which is they have hemoglobin in there, which is the protein that makes blood red. You're like, how the hell are they getting hemoglobin in there? There's not a lot of blood in plants. What are they doing? What Impossible did was they took brewer's yeast, like you would use to make beer. They get the gene for hemoglobin, just like Genentech did back with insulin in the 80s, okay? And they put it into yeast, they brew it up, and they make heme
So instead
with
of
no
beer
cow.
coming out,
Instead of beer, you get heme. And then you add that to a burger, and suddenly it smells right, tastes right, it's Impossible Whopper at Burger King. That is a product that is like a disruptive hamburger product. It tastes so good because there is a animal protein in there with no animal. Well, that magic trick is accomplished with synthetic biology.
You guys are
Right.
Houdini.
You have no idea. Like at this point, the stuff our ability to design biology today, like in the arc of what's going to be possible, is a joke. Right? It's like computers in the 50s or something, right? Like we're just like banging around there, like it is. There's so much room for improvement in our ability to design. We're just doing the absolute lowest hanging fruits today, right? And so there are some great ones. And so we have a company on our platform called Motif Foodworks. It's a company that we announced 2.5 years ago, had raised, I think they started by raising $90 million and started on the platform day one. So they never built a lab, right? Well, we've helped them over the last 2.5 years to get yeast to produce proteins like that, animal proteins. They just announced 2 weeks ago, they raised $226 million.
Oh, that's awesome.
Yeah, they're killing it, and Ginkgo, we're a shareholder, right? Because our business model is if you're building on the platform, you either want a royalty, like kind of like you'd have on an app store revenue stream, or in lieu of a royalty, equity.
Yep.
Okay, and so that's a model for us where if you're going to start a company today, instead of spending all this upfront cost on a lab, just build on top of Ginkgo.
Yep.
That's the idea. Yep.
You guys provide the foundation for them to.
Yeah, and then they can go to market with that great app, right? And so that's sort of what we want to do. We want to basically enable all those companies to grow on the platform. Yeah.
That's amazing. Awesome.
But there's a lot of low-hanging fruit in food.
It's a lot to wrap your mind around, but you explain it so well. So thank you.
Well, it's kind of like saying like what are going to be the apps on phones when the iPhone came out in 08. It's like, people could have speculated, but what you really wanted to do was create the conditions for people to innovate and come up with all those apps. So like I have no idea, right? Like what the great synthetic biology.
The TikTok of 2030.
Yeah, like what is that going to be?
Bring back Vine.
Right? Like it's up to our customers to figure that out, and we just want to make sure that they have the highest likelihood of success by virtue of all the platform tools we give them to do that. And then we're just happy to sit back and be impressed, right? Yeah.
Well, that's phenomenal what you guys have been doing in many other sectors. And we've talked about biotech and how it started for diabetes. But But in 2020, we've seen what was the biggest hit, and there was a big highlight when it came to pharmaceuticals and health because of COVID-19. Can you tell us a little bit of how COVID-19 affected Ginkgo, and has Ginkgo pivoted to meet the demands on the new way of living?
Yeah, so this was a big, 2020 was a wild year to be in biology. Yeah, I mean, so what happened was back in March, when it was became obvious this thing wasn't going to go away, we sat down, some leadership at Ginkgo, and it was kind of like, well, this is kind of the biological event of our generation, and if this was a computer virus, would Google sit it out, right? So we should find some way to help. And so we did the usual Ginkgo thing. We were just open-minded about it. We're like, well, we got a platform. Who needs help? And we said we do $25 million of free platform work. That led to a project we did with Moderna, for example, but also a bunch of other work with folks doing protein therapeutics and academics that needed gene synthesis of various proteins in the genome of SARS-CoV-2 and so on. It was just plug in. Yeah. And then the other area we spent time on was in surveillance testing. So you're a meteorologist, right?
Yes.
In previous life. So what's interesting is we have a whole diagnostic testing industry, which you might remember all the stuff in 2020. It's do we have enough tests and all that stuff, right? If you're a diagnostic test, you're sick, you go to the doctor and they're like, you should get a test, and you can walk over down to the lab and take a test, right?
Yeah.
All right. Surveillance testing is, I want to keep a school open. I want to keep a workplace open pre-vaccination. Right? Can I test people so that I know if someone has it, I send them home before we have an outbreak in the workplace or the school? And that's an industry that is new, hasn't existed. And you only need it in the midst of a pandemic. It's like a biosecurity function, not like a health function. Does that make sense?
Yeah, that makes sense.
You wouldn't otherwise get a test because it's Tuesday, right? But under a pandemic environment, you would. We were testing people here at Ginkgo twice a week, right? And so that became what we call our brand Concentric, which is now doing a lot of K-12 testing in the country. We're statewide testing in Massachusetts. We're sole source contract in Arizona. We announced sole source contract in Maine. We're statewide in New Hampshire. The list is going up because these schools are getting ready for the fall, where kids under 12 aren't vaccinated. You have Delta variant going up, so you have this issue coming up where it's how are we going to keep the schools open because parents aren't going to tolerate a year like we had last year with kids.
Absolutely.
And so that is another tool that just kind of grew up because we said, well, where can we be useful where there isn't somebody already who's done it? And so that was sort of surveillance testing was that category, and then where there's great people like a Moderna, can we help? And that was our approach. And I'm proud of the work we did last year. It was a lot of work, and the team did a ton of work in the midst of a very difficult situation. So yeah, I think it was great.
That's fantastic. I love hearing that.
Well, so we know the cost of biology, it's expensive. The DNA sequencing and the synthesis has drastically become more affordable.
Yeah.
So this is a two-parter. What does that mean for Ginkgo? Does that mean more higher rate of production for you guys?
Yep.
And then why is biology still considered expensive? We saw all those fancy robotics.
Yeah, sure. Okay, yeah. So I'll give you a little piece of the theory, and then Emery, maybe you can talk a little bit about the economics of a project for a customer. So all right. So here's the big difference between programming a computer and programming a cell.
Sure.
If you're a computer programmer and you put new code into the computer, it's free.
Yep.
Right? It's just bits flying around your process. It's a little infinitesimal amount of energy or something, but it's basically free. All the cost is just your butt sitting in the chair getting paid by Google to do the programming, right?
Yep.
Okay? Cells, they run on digital code that's programmable, but it's not virtual code. It's physical. A piece of DNA is an actual molecule. A, T, C's, and G's are chemicals. And so we have to actually build that DNA when we compile code in. And that physicality means that you need infrastructure.
Yeah. And
the big learning of Ginkgo was the way that, by the way, you program cells pre-Ginkgo, it was what I did in grad school. You hunch over a lab bench and you get PhD training, 5 years to learn how to move what liquids and what things, to do it very carefully and do the careful experiments, to do it all by hand.
Yep.
And what we said was, let's move that all to automation and treat it like manufacturing with quality control and drive costs down with scale.
Which we've seen, and it's beyond impressive.
Yeah, I'm starting to get impressed by it. Right? It's pretty cool. We've been at this for 20 years, mind you, right? We met the founders of that in 2002 at MIT, and recently I've been this is starting to get freaking cool. Having that is our core competitive advantage, is that scale, providing us with lower cost to compile and debug code. But it's still, you want to talk about like just the economics of a project we would do with a customer like a Motif or something?
Yeah, absolutely. So yeah, Jason mentioned we've got like these two kind of core value drivers with the program. So what the customer is experiencing is, I've got a budget, I want to make a product. What is the best shot of success I have to make that product, right? And so when they come to Ginkgo, the first thing that they're paying attention to is, how much experimentation can Ginkgo do in that foundry you guys toured around for my budget for R&D work? And so that's the piece of the equation that we want to bring as low as possible, like make it as affordable and easy as possible for a customer, a Motif today, a 14-year-old kid with a laptop in the future, to program something responsibly with biology. And so what we're doing is we're passing those cost savings that we experience from DNA sequencing and synthesis, from our scale economics in the foundry, back to the customer in the form of lower cost to program. And then we recognize that as revenue for the foundry services we're providing. And then any other value we get, and this is where we see the majority of the value for the business, is we take that share of the downstream value that's created when they ultimately commercialize a product. And from the customer's perspective, they're like, win-win. I get a product to market, I'm successful, you win. Like, I'm used to a world where I'm pipetting with my two hands and I fail 99.999% of the time. So like, God bless. Like, if I'm successful, Ginkgo, take your share, and that's a great model for them.
Win-win across the board.
Well, that's where I want to say, like, when it comes to like Ginkgo generating revenue, that business model is fantastic. Like, you being able to work with so many other companies and help them grow and create those cells, that's exactly what makes a business successful.
Yeah.
Like, being able to not be in one specific sector, but in many, in perpetuity. Like, you have, if I may, I say this to all my followers, I say this to my coworkers, and I say, you don't know what Ginkgo is, here's what it is. And Jason just put it perfectly as well as you, is that you pay me for 3 to 4 years of working with my foundry, and we'll create a sample for the product that you want to create. As soon as we're done, whether it be before that time frame or we are done, we create the sample. This is your sample. And once we're done, I get 10% of that, or whatever amount, in perpetuity. Yeah. And people don't understand that. Like, you get that for the lifetime of that product which that company sells.
Just like an app store.
Exactly. But
and because it's so diversified, there's a very large market of potential applications, pens people can make with those applications. So they're, even though we only want to take a small piece of the value of that product, so our customers are the big winners here, there's a huge market there for us to go after and build a really valuable business.
Well, this was a question I had for you down the road here, but do you guys just consider yourself an incubator for like early stage startups then? You provide this mentorship, access to your platform, and in exchange for equity? Is that
it's
a way of describing yourself?
For startups, it's not too far off, right? And like, who I like who's done, I think, great work in this space is Stripe, right? So if you look at how Stripe approaches the world, they're like, I want more startups on the internet running on Stripe. They do things like they'll give you a loan, and then you can you pay your loan back out of Stripe rev share, right? Because they take a cut on all the transactions, and they're like, until your loan is paid back, it's at a higher price, a percentage, and then it goes to the normal Stripe percentage. But we want to help you boot your business up, because in general, the more GDP on the internet is more money for Stripe, right? And like, I'm like doing the exact same shit. It's like bigger GDP of cell programs is more for Ginkgo. I want to make it as easy as possible for people to launch programs. And that does include, I think, particularly for startups, because I cannot emphasize enough, the upfront costs of launching a startup today in biotech are $5 or $10 million compared to an app which you can pop up your computer in a freaking coffee shop for nothing. I want to make it more like that, right? And the answer is, you don't build a lab. You use my cloud lab here, and I do all that. You don't even have to hire scientists. I'll use my scientists. You focus on what you're good at, which is, if you were, say, Motif, that food company, food science. Making the burger, engaging commercially with food companies, all that stuff. You don't need to be biotech people. I'll take care of that.
Well, in a sense, you guys are going to accelerate so much progress in these areas that we've been talking about because of the platform you're providing.
That's my hope. I actually think you can get a whole new generation of entrepreneurs who are like in the markets and and are passionate to go disrupt those markets. They don't have to be deep in the biotechnology.
To provide that type of opportunity and to be able to not only invest into them overall and help them grow, but also to have a piece of that pie while it grows, it not only helps yourself but them. What I want to say is, when you said that you have currently, you have 70 projects, right?
Yeah, so
And-
we've done 70 in the history of the company. We ended last year with 48 active cell programs we're doing for customers. To give you a sense of scale, we're adding 23 this year.
And what do you want to have by 2025? What was the
500 new ones on the
500.
platform. Yeah.
So what I want my followers to kind of understand, that's 500 projects, 500 streams of revenue,
Yeah.
which people don't understand. And if people take that in perspective and look at the current valuation of the company, what it could be,
Yeah.
the hypergrowth is ready.
I don't think
You're on the
that's
cusp of
revenue
it.
for you.
Well, the thing is you're at the cusp of hypergrowth. People just don't understand.
Yeah.
Like your valuation, in looking at the facility that we just toured, like it hits the value.
Yeah.
I think what's really exciting is this is probably the first year where we have seen and we'll continue to see, I think, some real wins come off the platform. So you saw what happened with Motif. Jason mentioned they just raised a big round on the basis of announcing two products that they're launching based on the work that they've done with us. You saw Cronos just announced that they're going to begin commercialization of a key program that they've worked on with us. So, I think you're going to start seeing that downstream portion come to life.
Yeah, Cronos is a good example, right? So this is a Canadian cannabis company. It's half owned by Altria. And we did a deal with them, I guess, probably 3 or 4 years ago now, where they're like, all right, right now we basically grow these giant fields of cannabis in these big greenhouses up in Canada. It has a pretty big, expensive footprint.
Oh, yeah.
Well, let's instead take a brewer's yeast, read the genome of the cannabis plant, find the part that produces the cannabinoids, move that into the yeast, so that when you brew it up, instead of beer, you're going to start getting cannabinoids. And so they just announced their first commercial runs for CBG, which is one of the rare cannabinoids, made now with a cell that Ginkgo programmed for them.
That's a brewery I want to go to.
Yeah, seriously, right? I mean, tell me about it. And so, like, that's an example where they didn't have to become biotechnologists.
Well, we
right?
know too, though, there's certain cannabinoids that have these different medicinal values, one of which will suppress your appetite.
Yeah.
So you're telling me you guys could, yield that from yeast, and then we've got this suppressant, so I can lose weight?
So I think what I would like that. So I think what you will see is being able to make the individual cannabinoids.
Yeah.
So the advantage of a engineered cell to produce those versus taking it from the plant is with the plant, you kind of get the mix that just is in the plant natively. And there are certain cannabinoids in there that are present at very, very low levels that are actually some of the ones that people find more interesting, either pharmaceutically or for various consumer goods uses. And so being able to make those in a pure form via the fermentation actually does open up potentially new markets, and that's exactly what you see going on with Cronos now. People want to,
wow.
yeah. So I don't know what who knows what that you have to see in practice what actually is capable, but you'll now have access to those molecules, right? That's the new thing. So we'll see. Yeah.
Awesome. So you guys have not that much time left, but if we can ask one more question. Yeah. So you talked about helping with startup companies building out, and you've obviously helped with Moderna grow, and they've seen hyper growth because of the demand of their product clearly for the vaccine. But can you share if there's any potential that you guys want to work with the United States government for a potential project pipeline for them? You guys basically have a Rolodex full of companies that you worked with, but is the government involved at all in this in the future, if you may say?
Yeah. So 100%. Yeah, I mean, we have a team here that really focuses on the government explicitly. I think this was sort of put in we have historically, we've done work with DARPA, IARPA, more on the research side.
Mm-hmm.
What changed in the last year and a half in the context of the COVID work was we started to do more of engaging with the government more in a procurement manner, right? Mm-hmm. Particularly with the stuff we're doing in Concentric. So that K-12 testing, there's what basically happened was the federal government, once Biden took over, decided they wanted to deploy surveillance testing. They gave $10 billion to the states for K-12 school testing just for this fall and spring.
Wow.
And so every state by population got handed checks 3 months ago. California's got $800 million, Florida's got it's a lot. And then they're saying, okay, let's use that to make sure the schools stay open. And so when we're doing these contracts, we're engaging with the states via basically federal money that they've been given for biosecurity. And so so my view on this is it's a great thing for Ginkgo to be involved in. It's obviously a good near-term opportunity for us commercially, but it's also the beginnings of biosecurity, right? And my view on the U.S. government is look, we're entering an era where we can program biology like we program computers, and we just found out that 30,000 letters of RNA puts the country on its ass for 2 years. Right, even with the miracle that was mRNA drugs,
Sure.
like we're not like that's not an acceptable national security footing from my standpoint, right? And so we as a country should get better at biosecurity, and the beauty of it as a consequence, we're just getting better at public health.
Yeah.
And then we should deploy that technology because the U.S. is freaking good at this internationally. This is exactly what we do. We do this with missile defense, for Christ's sake, right? Like we should be out there providing global biosecurity so that no one ever tries to weaponize this stuff or do anything with biology that's malicious. And instead, it's like U.S. has that sort of like shield, right? And I think this is believe it or not, this stuff with K-12 testing is the beginning of that because it's an actual material investment in biosecurity. Same with the mRNA vaccines, Project Warp Drive, same thing. So I do think you're going to see more from the U.S. government in that area of biosecurity, but it's very unknown exactly what it's going to look like, and we'll have to see.
Well, I can't thank you guys enough for this comprehensive deep dive today. I know that there's a lot for us to digest, but for our followers, I think this is a better understanding of what you guys are doing and then just wrapping our minds around what you're capable of doing. So thank you again for taking this time.
Yeah, thank you guys for doing this. Again, I think it's really important that in general, as many people as possible understand what's happening in synthetic biology, and obviously, Ginkgo specifically. But it's important. So thanks for it.
Absolutely.
Thanks for coming in.
Thank you, Jason. Again, Marie. I appreciate it.
Thanks.
Bye, guys.